Hi. So in yesterday's class, we saw some, balanced equation, and I have given some assignment also, and I got good answers from you people. So again, if you have any doubt, please do ask. If you are unable to solve those assignment questions, the second one will be, I think, for you it might be typical, right? So what was that? Methane reacts with oxygen, right? Whenever the methane reacts with oxygen, oxygen means again a gas. There are we have to represent it with the diatomic form to form or to give carbon dioxide and water. So simply we will write carbon dioxide and water. So how many of you did it correctly, I don't know. But once you check your answer here, right? CH4 plus oxygen O2 gives carbon dioxide plus water molecule. So these are the two different things what we got in the product side. So here, see, now you can go for what balancing. So here it is bit typical. I mean, very easy if you repeatedly do these type of reactions. Then these reactions will be very easy for you. But if you only listen these classes and if you left them like that only, then it will be very difficult. Why? Because you require attention first of all, and then you have to try it repeatedly. Otherwise, these reactions will not come easily, right? We have to repeatedly go for why? Because there is no what shortcut to remember how to remember reactions. So we have to, when you start doing or practicing more reaction, then definitely you will come to know everything about that particular element or atom or species, right? So this is a very small advice for you people. So practice it. Whenever there is a time, free time, definitely you take one reaction and simply you balance that. And then there will be a definitely doubt will come, and then you can ask us, right? So now there are three elements here: carbon, hydrogen, and oxygen. So first you go for carbon, right? So check. In the reactant side there is only one carbon. Now you check whether one carbon is present at the product side or not. So here the carbon case is okay. I mean, at the reactant side also there is a one carbon, and at the product side also one carbon only. So thus carbon is balanced. Now next is oxygen is with both, carbon as well as with the hydrogen. So that's why oxygen directly before going to this, or else you can go for this only, right? Okay, no problem. You can directly go for balancing the oxygen, or else you can balance this and then later you can balance the oxygen. So now see, at reactant side there are four hydrogens, right? Four hydrogens. So now you check here. Here only two hydrogens are there. So that means what we need to do, we have to multiply. Multiply with what? 2, right? 2 2s are 4. So now go for final, that means oxygen, last one. So here in reactant side there are 2 oxygen, but at the product side 2 plus 2, 4 oxygen. So it is very simple. So now if you multiply again this oxygen with 2, then definitely your answer, I mean the reaction will be balanced or reaction is balanced now. So likewise, you can try some more examples, right? Reactions. So it will be very easy for you now. So today we will go for one more very important basic part of the chemistry, that is valence. Alright. This is very important. Valency is very important. Based on valency only, one we can write more than 70% of reaction. I mean all the reaction, not 70%. More than 99% of reaction will be based on what? Valency. So that means what is it? What is valency? So valency is nothing but the ability of an atom to form a bond. That's all. The ability of an element to form a bond. That means that ability, how this ability will come in any atom. That is very important. So that means, see here, the number of electron present in the valence cell, right? The number of electron present in the valence cell. Valence cell means valence cell is also called outermost cell or outer cell, we can say, last cell, right? So outer cell we can say. So valency is nothing but outer, the number of electron present in the outermost cell or the last cell, they all involved in the formation of bond, right? Though I mean, if one electron is present in the valence cell, definitely that electron will undergo into the formation of bond with what other element. That is nothing but that valence of particular element. So take one example, hydrogen. We will start with very basic hydrogen. So here the Z value, I mean the atomic number of hydrogen is 1, and now I can write, I mean electron configuration like 1s1. So that means there is only one principal cell and there is only one electron in the what? Hydrogen. So that's why this electron must and should go and form a bond with other element. That is nothing but the valency. Now, if I ask what is the valency of hydrogen means, what do you say based on what? Outer cell. The number of electron present in the outermost cell is nothing but the valency of that particular element. I mean, for hydrogen, how many number of electrons are present in the valence cell? There is only one cell, that is only the valence cell itself. So thus, only one electron. So therefore, the valency of hydrogen is 1. Why? Because why we only considering the outermost electron means in chemistry, right? The outermost cell is very important, or else the valence cell is very important. The number of electron present in the valence cell only involved in the formation of bond. So that's why those electrons only we are considering, right? So this is the case. So that's why always, because of one valency, always we see a single bond with what? Hydrogen. Very important it is. So why we are seeing just only one single bond with the hydrogen means because its valency is 1. That means it can donate only one electron and attract other species towards itself. I mean, it will show there is only one electron with me. To complete it octet state, I mean stable state, it requires how many? One more electron to complete this S subshell. So thus it donates only one electron. So that's why with hydrogen always there is a single bond, right? So now if you have any doubt, please do ask, right? So this is a very important part, right? Valency is nothing but again the number of electron present in the valence cell are nothing but the valency, and those valence electron will undergo into the formation of a bond with other elements. So that's why those are called as valence cell electrons, right? So now we will see one more. We will take one more example of lithium. Here, the lithium, the atomic number of lithium is 3. And now, what I can write is 1s2, electronic configuration is like this. So now, see here, there are two principal cells, 1 and 2. Now, this cell electron is not important for us. Why? Because the outermost cell is different here. Second cell is outermost cell, not first cell here. So that's why the number of electron present in the valence shell will undergo into the formation of a bond. So that's why the valency of lithium is always 1. So therefore, whenever you see the bond formation with the lithium, always it will be 1 only. Right? Very important. So now you can have many examples like this, right? So lithium, and then you can go with the period, right? Beryllium. Beryllium means 4, 1s2, 2s2, 2 plus 2, 4. So thus completed. I mean, the number of electrons are complete. So now here also we have two cells, but in valence cell, how many electrons we have? 2 electrons, very important. So thus, beryllium always shows 2 bonds around it, right? So it's very simple. The number of electron present in the valence cell are nothing but the valency of that particular element. In case of carbon, right? So already I have explained about the carbon during organic explanation, some basic concepts of organic explanation during that class. I have already explained. Carbon means C, 6, right? And 6 is nothing but C, 1s2, 2s2, 2p2. Now, again we are at the second cell only, but in second cell now we have how many number of electrons? There are 4 electrons. So that's why around the carbon we see always a 4 bonds, right? We see always a 4 bonds. Why? Because there are 4 electrons in the carbon, in the valence shell of carbon. So that's why carbon always shows a 4 bond around it, right? But now after carbon, see, chemistry is not so easy now. After carbon, so I will just show you this. You forgot or what, I don't know. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. Right? So this is the period, right? So now what I said, as we move from left to right in the period, definitely what happens? The electronegativity character increases. If the why? Because the size decreases. As the size decreases, electronegativity. Till here it's okay, right? Till here it's okay. But now here, from here on, what happens is the different type of electronic configuration, valency we see. Till here we can see the valency in positive form, but after carbon we see in negative form, right? How? We will check. Nitrogen. Nitrogen is having 7, 1s2, 2s2, 2p3. See, if you don't know about electronegativity, then definitely this class will not be understood. You will not get this class. Why? Because I have requested you people that please go through the electronegativity. If you are gone already, then okay. If you are not, then this class will be very difficult for you. And don't ask us, sir, why you are mentioning these, valency as a negative and these as positive, right? Why? Because electronegativity is less in these elements, but now electronegativity character goes on increases, right? Because due to that the size decreases. Size decreases means this nucleus will not allow this electron to remove so easily. So that's why the negative character remains on that particular element. So now here, in case of nitrogen, how many valence electrons are there? 5, right? See, very important. But nitrogen will not show 5 bonds around it. Very important, right? Why? Because see, what I said, the fulfilled orbit are completely half-filled orbit. Fulfilled orbit or half-filled orbits are more stable, and the inert pair effect comes in this. Inert pair effect means even though the this I mean yes, particularly s orbital, even though they are present at the valence shell, because of inert pair effect, those two electrons will not go for the formation of bond, they remain on the nitrogen itself. So that's why we always see the two dots on the nitrogen, right? Very important, because of its stability we can say, or else because of inert pair effect. During p block element we come across with this inert pair effect. Inert pair effect means the valence s orbital electrons will not undergo into the formation of a bond. So that type of effect is called as inert pair effect. Even though they are in the valence shell, because of its small size, nitrogen will not allow those electron for the formation of bond. It will retain those two electrons. Just these three electrons will go for the formation of bond. So that's why around nitrogen we always see three bonds. That means the nitrogen valency will be always -3, right? -3. Why? Because the electronegativity factor increases. And likewise here in case of oxygen 2, in case of fluorine 1. So in the next class we will go again in detail about these valencies. So just you go through it once or twice, and to understand this valency class, definitely you must and should have a good idea about the electronegativity. So this is the request. You go through the electronegativity, definitely you come to it. Right? So thank you.